I'd like to present a little puzzle that might be effective in getting young students, elementary school students, to think about science, critical thinking kind of thing. I have in this coffee container some objects. In fact, there are 20 objects in the container. And we're going to kind of investigate what might be in there. Are they all the same? Are they different? How many different kinds of objects are in there? And the first thing that I'm going to present to the students is the masses of the objects. I've massed them to 1/100th of a gram, and we're going to present them on a spreadsheet and look at the results and see if we can make any conclusions about what's in this coffee container. Okay, here we have the 20 masses of the 20 objects, and let's see if we can make any conclusions. Let's begin by just let's look at a scatter plot. Okay, I won't put the axes on, but we have the mass on the ordinate and the number of the object. And you can see it seems like some are kind of low in mass and some are kind of high in mass. Is it just a variation? Are they all the same and they're just a variation, or are they really two kinds or more of masses? Let's take this column and duplicate it. And let's now sort that new column out. So we go to data and sort it from lowest to highest. And we don't want to do anything else to the other columns. Okay. Let's get rid of this chart. And let's make a new chart. We'll do a scatter. You could do a bar graph. So we've sorted them from lowest to highest. And you can see that there's one group of about 10 that seem to be similar. Of course, you know, these are changed from lowest to highest. And another group of about 10 that seem to be higher. Let's take the two groups and separate them. Let's take this, the last 10, I should say, cut it out of there and put it over here. And if I'm working with one of my grandkids or some young kids, I would say, well, let's get an average. And of course, you know how to get an average. Let me create a column here. So this will be the average. And I was able to show my granddaughter how to use Excel and the basics of Excel in a short order. I'll just do it this way, but I think it's useful to do it the long way. Just sum up all the numbers and divide by 10 in this case. Okay, so the average of the lighter ones is 6.42. And the average of the heavy ones is 8.58. Okay, now this chart got all screwed up because, let's just get rid of it. We could get, if you have older students, you can get standard deviation, and you could say, are these significantly different than one another? And I'm sure that you will find that they are, but you can't really do that with real young kids. But that they are certainly different than one another. So the kids come to the conclusion that there are two kinds of objects, at least, in there. Now, how else might they differ? And we can peek in and maybe take one out and look at it, and we'll go and do that next. Okay, well, I think the students have established that there are at least two kinds of objects in this container, 10 of one type and 10 of another. Now, there may be more categories, we'll see. Without looking directly at them, one of the things I tried, I have a light pipe, and I kind of looked in and moved the light pipe around, and it's a little hard to see with this, but it seems like two colors came up, blue and yellow. And I asked my granddaughter, and we were kind of exploring, is it possible that there's blue objects and yellow objects, and one of the objects, the blue has the lighter mass or the heavier mass, and the yellow has the heavier and the lighter, or vice versa. Is the color what distinguishes them, or is it that the objects differ in some other way? And we talked about this, and how would you find out, and just got her to think, and it was not as good of a project as I had hoped, but I think it was a little bit effective, and I thought I'd pass it on. Well, let's take a look now at the results. Okay, well, we've got two objects that are blue. Okay, I didn't let them all out. Let's kind of let them out slowly. Oh, we have two cubes and two blue cylinders. Okay. Oh, looks like we've got quite an array here. Now, if you look at it carefully, you'll see that there are actually 10 cylinders, and 5 of them are yellow, and 5 of them are blue. If you're dealing with real young kids, you might kind of engage them. Is it the color that makes the difference in mass, or is it the shape? And of course, unless the kid is pretty young, they'll say the shape, all right? But how will we test it? Well, we could actually weigh them and look. We could weigh them when you actually see them. And then the question came up, is there any significant difference between the mass of the blue ones of the same shape as the yellow ones? And that's something, depending on how old the kids are, you could weigh them and look at this average and the standard deviation. Is there a statistically significant difference in the mass of the blue cubes and the yellow cubes, and likewise for the blue and the yellow spheres? Obviously, an elementary school kid would not be able to comprehend this kind of thing, but a high school kid might. So it's just an idea I throw out there for you to look at, and maybe it'd be something useful that you can use with your kids, your grandkids, or your elementary school kids, or even your high school kids. So I thank you for your attention, and I'll see you next time.